Hello everyone, welcome to another episode of Neural with Mohit. And previously we learned, like in our last episode, we have actually learned about the context engineering in RAG. And today we are again here to discuss something very important, something which is emerging nowadays, and that is agents, right? And I am very sure that you must have already worked with some of the LLM frameworks where something like LangChain or LangGraph, which you have seen, which are one of the most popular frameworks, and they are used in the industry, in the production environments a lot. Okay. From the same LangChain community, we have something called now deep agents. Okay, because nowadays there is a very high rise of agentic frameworks, which are like autonomous systems, which are able to do the task by its own with, I would say, low to zero supervision required, right? Anybody who has worked with LangChain and LangGraph, they understand that, like for an example, LangChain is actually used to make simple app workflows, right? Whereas LangGraph was giving you some more capability, where you can do some conditional behavior, conditional flows on that. But more or less, LangGraph also we used to use it to make the we used to use it for the deterministic flows, right? Now comes the thing is, okay, the world is moving towards agent deterministic flows and all. You need to know what to do in what scenario, right? So you still need some intelligence from our side, but the decisioning is not at our end at the moment, correct? So LangChain community has given us another framework which is called the deep agents, which is kind of a super autonomous framework. So what it does is you give it set of tools, you give it a command, and this agent will figure out what to do in what exact scenario. Okay, so let us understand what deep agents are, and then after that we will jump into the coding part of this. Okay, so DeepAgent is a standalone library built on top of LangChain's core building blocks for agents, right? So you must have noticed, if you're following the LangChain community, you must have noticed that LangChain has recently introduced agents also in their libraries, right? But those agents, again, since the LangChain itself is not that autonomous, those agents limitations were there, right? And then if you have to use those agents, you have to use the memory of that, you have to maintain each and every thing in that particular agent, and it was kind of very managed kind of system where you have to take care of a lot of things, right? So the reason for introducing deep agents is that it will be a completely agentic framework for you, where there will be very less what we say dependency on you when you are developing it, and most of the decisionings and other things the agent itself will be taking. Okay, so it uses the LangGraph runtime for durable execution, streaming, human in the loop, and other features. So you can see that because LangChain and LangGraph are so established, they introduce a new deep agent which is built on top of this, right? So it has taken the agent capability from the LangChain, and then it has taken the capability of LangGraphs in for the long running task, for the streaming services, for bringing in human in the loop for any decisioning and kind of things. Think of deep agent as an agent harness. It is some core tool calling loop as other agent frameworks, but with built-in tools and capabilities, right? So what does it mean? It means that you can think of this where it is able to break down a big problem into simple thoughts. On those thoughts, it is able to take some actions, and after those actions are taken, it is able to do an observation on top of that to see that whether the desired result is currently there or not there. If it is not there, okay, what next action should I take? So kind of that it is able to break that complex problem into simpler versions, and then it is able to take decisions on top of that. Okay, like if we'll quickly see agent, how does it work? So it works like you have a problem statement. That problem statement can be broken down into multiple thoughts. Now for each thought you can have an action, right? And a thought can be a kind of a dependent thought also, that okay, to achieve this one I have to complete this one first, right? So all that decisioning, all that understanding, agents take by themselves, and then they hit an action. From that action you get some result. That result is again observed, and then we see that, okay, what should be the next thought now? Do we have the result that we were looking for? If not, go to the next thought, take the action, observe the result, again same. So like this keeps on going until unless you actually arrive to a final answer, right? And you can also put how many number of tries you actually want to have in that, right? How many steps should be there. Okay, so let's understand deep agents in a nutshell. It is a goal-driven, framework, which is like it breaks complex tasks into smaller steps. It thinks plus acts. So as I said that, there is a thought and there is an action, and iteratively it reasons and uses tools, right? Then there is a memory to keep track of what it has done previously and what it has to do next. It handles the workflows. It is able to make decisions on what to call next, what flow should be following for a very long running task as well. And it is a kind of a semi-autonomous framework where it plans and executes with minimal guidance, right? If you have used LangGraph and LangChain, you must have seen that the flows over there were too decided, right? But here it is not like that. Here the agent is going to take that decision for you. And in that you also have the capability of adding a human for any decisioning where you do not want the agent to decide by itself. So there you can bring in humans also. Okay, so as we were discussing, it is by the same community, so we will quickly discuss on the differences between the LangChain, LangGraph and DeepAgents. Okay, so what is the core idea of that? So the core idea for LangChain was that it is an LLM app framework. Okay, so basically a very simple LLM app if you have to make, which will be having a pipeline kind of a flow, where the input will be there, LLM will be executing that, you will be getting some result. On that result you have to do some JSON parsing, and also simple, very simple flow you do this. Okay, LangGraph, this was mainly used for a graph based agents, right? So when I say graph based agent, it means that there could be multiple nodes which are parallelly working. They are bringing in result, you are maintaining the states of that, and then those results are used in the next node, let's suppose, right? But the flow here is kind of it's kind of a workflow only, right? So you know what is going to happen because you have only designed that complete flow, so it is very deterministic for you. Now if you will come to the deep agents, they are the autonomous. You do not know what is going to happen there. The agent itself will decide, okay, to achieve this task, now I have to do this. Okay, now comes to the structure. As I said, it is chains and tools basically. Here you will be having nodes and edges, just like how you have a graph, just like that. Here how will it be doing is, it will be having a goal, it will plan for that, and then it will take an action for that. Then again it will observe its value, again the same cycle will continue. Okay, what is the complexity? The complexity for LangChain is medium, obviously, right? For LangGraph it is high, and for agents it is very high, right? What about the control? LangChain, I have written moderate, but I can say simple here also, right? So because here you know that how to do that. The only reason I've written moderate here is because otherwise I can do a pipeline also, like I can write a pipeline myself and do that, right? So that will become a more simple to me. For LangGraph, the control is kind of high for you. You have decided what you want to do over here, right? So that whole thing you yourself have decided that, okay, after this node this should be executed, or these three should be executed. So you are actually joining each edge with each edge, right? What about deep agents? Deep agents, they are very, very, very autonomous, right? So you actually do not define the workflows over there. You do not define what should be the control over there. Okay, so memory, LangChain, since it was for very simple applications, the memory is not that high thing over there. However, in LangChain, if you have seen that we generally use the LangGraph memory only, right? For LangGraph, again, I would say it's persistent plus state flows, right? You can put the checkpoints and all as well in this LangChain, because you are using this LangGraph's memory saver. Okay, and in LangGraph you can define your own states, and then you can give those states itself in your workflow, saying okay, I want to store in this particular thing, right? For deep agents, it is a built-in long horizon memory which actually takes care of each step it has taken, each decision it has taken. All that is persisted over there for you. Okay, what are the use cases? It is used for simple moderate apps. Yeah, definitely. This is used for deterministic workflows. The workflows are complex than the LangChain, like LangChain flows. But here it is still deterministic for you, right? Here for deep agents, it is open-ended. It is made for solving your problems, like made for solving the dynamic problems, and we will see example of those once we will jump into code. Okay, autonomous, it is very low. Autonomous means everything you have decided. For LangGraph, I won't call it autonomous, but still here you can bring in loops and all, where some kind of decisioning can be taken by putting in if else and all, right? But for deep agents, you don't need to do anything. You will just give a problem statement, your set of tools, and it will decide what to do. Okay, so this we have already discussed. Let's quickly understand that how deep agents work before we jump into the code. And please keep in mind that in today's session, the code that we are going to see, that is going to be a little complex. So you might need to pause the video at some places, understand the code. And I would also advise you, once I do a code walkthrough, you should also code on the side, not while I'm explaining you, but I would say that you understand the complete, and then you try and implement it yourself. If you are not able to understand some part of it, then you again go to that part of the video, you understand that part, and then again try it yourself. Okay, that is very important for today's session. Okay, so we will be having an agent. The agent will break down the complex problem into set of thoughts. On those thoughts, it will take action. For that action, it will be having tools and all at its service. So what it will be doing is it will be calling these, and once the tool is executed, you will be having some result, which again goes to the observation for it, where it will try and observe whether I have arrived to the final result or not. Until it is not, then again this whole process will be executed for you, right? Once you have the final result, then it will be giving you the result, right? And you can see here all this decisioning and everything agent itself is taking. We are not putting anything over here, right? So now let us jump into the code without any further ado. So yeah, so here we are going to use the deep agents. Before I go there, let me also show you that the kind of libraries we are using in this. A lot of libraries are there for the other projects also. You can see that I was working on a complete tutorial for you for different agents. So yeah, I'll tell you which one we are going to use for this for this deep agents. So we'll be using those one, right? So you will definitely need LangChain community. You will need. I am using Google Gemini model in the LangChain, so that's why I have to install this LangChain Google Gen AI as well. Okay, and then apart from this, I believe this deep agents is what you need. Okay, so let me just bring these here so that okay, then in one of the example you will see that I'll do some web search. So I have used Taveli in this, so you can use that Taveli as well. Okay, let me just bring all this LangChain at one place so that it will be easier for us to do these things. Okay, now let us come to this agent, right? Okay, so for this agent, I'll first give you the background of what we are doing. In this agent, I have given it two tools basically, right? I have given it one tool called the get city coordinates and another tool called get weather with coordinates. Okay, and for this we are using the weather API. You must have already seen that it is very famous open weather map API that we are using, right? So for this you have to go to the open weather map and you have to create your API key over there so that you can actually use it. So let's suppose I'll say login, right? And then let's suppose I do this. So what I can do is I can come here and you can see that the API keys and everything is present, right? So you have to use your API key over here, and yeah, so basically once it is there, what you can do is you can give your API key in the system, and that API key will be used for making the OpenAI calls. Okay. I would say that you have to create your own API key. Don't My API key you don't have to use. You have to create your own. Okay. So let's come here and let's see that what I am doing in this. So for parsing the result, what I am doing is I have created a class over here from the response, and this class is actually containing the country, the longitude, the latitude, the local names over there, and the name of that city, right? And you can see that it is going to be a list of those. So I might be picking one of that and then doing my thing on it. Okay. In terms of the usage, what we are doing is we are having this base model and root model used in this Pydantic class, right? And then there are this types being used. So from the typing, these are imported. Then I'm doing some JSON parsing, so that is why JSON is there. I will be making a network call, so that is why requests is imported, right? And then for the LangChain, I'll be using this memory saver, so that is why LangChain memory saver is being used. And as I told you that the LangChain also uses the LangGraphs memory only, right? So you can see over here langgraph.checkpoint.memory is what has been used, right? And the Gemini model that we are going to use, we are going to use it using the LangChain chat Google generative AI class. Okay. Then to load my environment file, which is over here, I have declared the variables over there. So I will be calling these to load my environment file. Now from here, the important thing starts for you. So for using the deep agent, we will be using the create deep agent function basically. And this can be found inside the DeepAgents library. Okay, so you have to say from DeepAgents import create deep agent. Okay, now this again is to parse my response, and these are the two functions. There's no need to like explain this much. It is like the get city coordinates will be like, it will take an input parameter as a city. Let's suppose I'll say Bangalore. Okay, so it will take Bangalore, it will hit the OpenAI, and it will say, okay, give me the coordinates of Bangalore, right? So you will be having a coordinates. Now from that, what I am doing is I am picking the first one, okay, and then I am just giving it back. So I'll be giving the latitude and the longitude in my response, right? And then I will be doing that. Okay, so once I have the latitude and the longitude of the city, right? So what I can do is I can call this function, right? And this function actually takes latitude and longitude, and based on that it will give me the weather updates. Okay, so those updates will be returned from here, and you can see that I'm doing a JSON passing on that, and I'll be returning as a JSON, right? Now these are the two functions which I have created, and you can see that I am not like I have commented tools, right? The reason for that is you don't need to specify your functions as tool in the deep agent, right? So this as I told you, it's a framework, right? So you just give it the function name and it understands that, okay, this will be a tool, right? So we'll be giving it in the tools parameter itself, right? Explicitly we don't need to define it as a tool and then make it to array and then give it like how you have to do it in the other frameworks at the moment, right? Okay, so here what we are doing is let's go to this model now. In this model you can see that we have chat Google generative AI model, and I'm using the Gemini 2.5 Flash with some temperature over here. Okay, and then this model I'm going to pass to my deep agent. Okay, so I'm creating a deep agent right now, and to this deep agent I'm saying that, okay, this is your name, this is the model you have to use, and these are the tools that are at your disposal, right? And this is the memory for you. So what you can do is you can use the check pointer memory for you. And once this agent is created, Then in LangChain you have seen LangChain and LangGraph that you have to invoke, right? So we will be invoking our agent, right? And when I'm invoking my agent, I will be passing the configuration like, okay, what will be the thread ID, and also that it will be able to store in the proper place. And in the message I am saying, okay, my role is user and this is my query. So what is my query? My query is what is the weather in Bangalore. Okay, so now you have to understand two things over here. Okay, number one, I have given it two functions, out of which one takes in the city and gives me the coordinates. The other takes in the coordinates and gives me the weather updates, right? To my LLM, sorry, not LLM, to my agent, I have not defined that what sequence you need to call it. I have asked my agent only to decide that particular thing, right? If I would have to code it myself, what I would have done is I would have first called the get city coordinates function. Once I have the results, I would have called get weather with coordinates function, right? Now let us see, I have already executed this, and let us see that how the agent has actually functioned. Okay, so when I've executed this file, you can see that first the function which is called is get city coordinates, and the argument that has been sent is Bangalore, right? So you will come in this function get city coordinates, and you will see that I have added a print statement over here with the argument that I have received, right? So you will see that it is telling you that I have sent Bangalore, and see my query is what is the weather in Bangalore. So my agent is able to understand, okay, in this the parameter is Bangalore, so I'll take the parameter, but I do not have any function at the moment which can give me the weather of Bangalore, right? So first what I need to do is I need to extract the coordinates of Bangalore. So it is calling this and it is getting the coordinates. Once that coordinate is extracted, so see it is giving it in the query and all. Once that coordinate is extracted, then it will be taking that result. So this is the result over here, and you can see the latitude and the longitudes are being given, right? So it will take that result and it will call my get weather with coordinates, right? And you can see that it is passing these coordinates in my get weather with coordinates, and you can see that the LLM itself is able to, not exactly again, not the LLM, the agent itself is able to identify and to decide that, okay, this is a sequence I should be calling to get a result. And this is how intelligent agents are. Now you don't have to define that flow for them. They will be able to do it by themselves, right? And once it has the result, it will be saying the weather in Bangalore is clear, sky with temperature of this much, and humidity of this much, wind of this much, right? So it is able to identify that complete thing for you. So this is a simple agent that we have discussed. The functionality is very simple in this. Now slowly we are going to move to the next one, where we are going to increase the complexity now. So right now what you have seen is I have given this agent two tools, right? And based on that it was able to identify, okay, I should call this tool first and I should call this tool second, and kind of this, right? And if I might have given it three tools with some different functionality, it would have been able to still figure out that, okay, what should I call and what sequence should I call, right? Now let us come to the next part. Now the next part is, what if I have two different agents? Let's suppose one agent for weather searching, one agent for the weather updates and another agent for web searching, right? I have two different agents, and the user gives me some query. How do I handle two different agents at my side, right? So in this case, what we will be doing is we will be creating an orchestrator agent, right? In LangGraph, if you would have been, you would have given, that complete flow at edge, at this condition, on this conditional flow, you have to, do all this thing. But here what we are going to do is we will be creating two different agents. Then those two agents we will give to our orchestrator agent. Now that orchestrator agent will decide that, okay, which agent do I have to call to solve which problem statement, okay? So we'll do the kind of similar thing, but here there are, few changes that I'll walk you through first. Okay, so change number one is that like here we will be having, like, change number one is basically uh, that we will be having one agent for weather updates. Okay, so this is the same weather function, so we are not discussing this again. Now here number one change is, as I told you, that for web search I'm going to use the Taveli. So this is the Taveli client that I'm creating. Now you will also learn how to use Taveli web search agent in this, right? So you have to get the API key from Taveli. So let's suppose, let me go to Taveli here. I will go to Taveli for you. Okay, so let's suppose I'm here. I'll do the login. Let me do the login using my Google. Okay, so once you do the login, you will be able to see your API keys over here, right? And you can actually create the keys that you want. So default keys there, they have a free limit quota that you can actually use to make the learning thing. So here you have the Taveli client giving the Taveli key, and what we are doing over here is, now we are having an internet search function. Okay, so I'm saying that I want maximum number of results to be 2, and I want to, let's suppose, search in these, and I am saying that don't include the raw content, just to limit the size of the content is what I'm doing. Okay, and I'm making this call, and then I'm sharing the results. Okay, now simple, easy, no rocket science till here. Then again, the same way, I have created the model there. Similarly, we are getting the model here again. Okay, now here is the thing. First, I'm creating a research agent, sub agent basically, where I'm giving a name to it, description to it, what should be my system prompt, what tools does it has access to, and which model is it using, right? Similarly, I am creating another agent called the weather agent, and if you see that my research agent has internet access, my weather agent has weather API access, and these two are completely two different skill sets for these agents, right? So this agent, if I'll call, it cannot tell you about the weather. This agent, if I call, it cannot tell you about the web search, right? So that's why the description is there. It also has the web search capability used to research more in-depth questions. Okay, this agent has the capability to call weather APIs and get the real-time weather details. Okay, so using this, I am able to tell it that what exactly these agents are able to do. Okay, now what I've done is I've created a sub-agent array, and this sub-agent array I have passed to my create deep agent this time, right? So you can see this sub-agent is there, this sub-agent array is being passed in this, and then the models are, the model is here, so I have given the model also. This time to my orchestrator I'm not giving any tool, so I've explicitly written it, right, that okay, I am not giving any tool to you because I want these agents to do that thing, right? Okay, now let's come to the invoking part. So here I'm saying, what is the weather in Bangalore and when did RCB win the IPL? If you are unsure on any information, then use the available tools and sub-agents. Okay, so what I've asked it is, I've asked it two different questions. Okay, what is the weather in Bangalore and when did RCB win the IPL, right? Now weather search, it will be able to do with the weather sub-agent, and internet search, it will be able to do with the research sub-agent, right? So let us make a call and see what all is it calling. Okay, so we'll say Python, we are in this, we want to run this. Okay, I'll just make it a bit bigger, and let me click on enter now. Okay, so now it will start calling the agent. So you can see that first it is calling the coordinate function, and it is getting the result. After getting the coordinate, it is like, okay, the weather in Bangalore is clear sky with the temperature this much and all, and have not won the IPL. So in this case, what you must have noticed is it is not able to identify that, hey, I have the agent that can do a web search for you, right? And this is where I said that you have less control on the flows here, right? Because here the agent itself is deciding whether it should be calling it or not calling it, right? So it decided by itself saying, hey, I don't have that weather search capability, even though it has one sub agent which is able to do that particular thing for you, correct? So let us also see that how we can make this agent now, we'll call it again and we'll see that how this will behave now. Okay, so now you can see that this time when I executed this program again, right? So it first made, it was like, okay, I need to get these information, right? So it first made the get coordinate call, then the coordinates are there. And after getting the coordinate, it is making the weather call. So definitely this function will give you the weather details, right? Then it is making the internet search call, right? And it has made the call and then it has received the result. And you can see the current weather in Bangalore is this. Royal Challenger Bangalore won their first ever IPL title on June 3, 2025 by defeating Punjab Kings, right? So now you can see and you understand as well, right, that if you're using the agent and they are autonomous, right, so they are the one who are going to decide what I can what flow do I have to do I have to answer from my internal knowledge, do I have to answer using the existing tools, do I have the tools available to do that particular thing, all these things they only decide. So it becomes super important for you to make sure that the kind of descriptions that you are giving, they should be elaborative enough for the agent to understand that, hey, I have this capability available. Because otherwise the agent sometimes hallucinate, right? So you can see that in the previous run only, it hallucinated and said that, hey, that no, it did not win, because it was trying to answer from its existing knowledge, and each LLM has a cutoff date, right? So it was only trying to answer from the date till when it was trained, and till when it was trained, during that time the RCB did not win the IPL. So it is like, no, it did not win. But the moment it did a web search, now it was having the real time information, and that real time data this time it has used to give you the result, right? So it is very important for you when you are designing an autonomous agent, you have to be very sure when you're deploying it in production that it should not hallucinate. Because for some of the places where if your agent doesn't behave correctly, then it becomes a huge problem also for you, right? So that is why even today in many production systems they still are hesitant in using the autonomous agent, rather they go for the LangGraph approach where they decide by themselves based on reasonings and all. Okay, cool. So we have understood simple agent, we have understood how we can do sub agents. Now let us also understand if I want to introduce a middleware. Now let's suppose what I want is I also want to see what my agent is doing, right? So at each step I want, before it is executing that, I want some functionality to execute, right? So that is called the middleware. So now let's come to the middleware implementation. This time I am implementing two new functions called wrap tool call and wrap model call. Okay, these are the two new functions that I will be executing. Now this is the model call count, it's an array, and this is the function. What it will be doing is it is just putting it over here that, okay, what number of the call is it, what model is going to do, what response did it receive, and like that it will be, right? So tool, similarly, what tool call is it, and what result is there, what it has called with, kind of all this attribute it will be putting in between. It is the exact same logic that I have done previously, so there is no logic change. The only difference that you will see this time will be like that I am putting a middleware on my tool calls. Okay, so here I am putting a middleware, right? Otherwise more or less it is same. Last time I was having two research agents instead of two different sub agents. Instead of that I am this time experimenting with only one research agent and the other one giving tools, right? Where my orchestrator agent is also having access to tools now. So it will decide that, okay, when can I use my own tools and answer a query versus when do I have to call the sub agent to answer a particular query, right? And each thought, like whatever it is going through, whatever it is thinking, that you will be able to clearly see, because I have added a middleware this time, which will be invoked each and every time we are calling the agents. Okay, so this time it is the third file that we are going to execute. So let us execute and see what results. Yeah, so let me also open a text edit for you, so that we can actually see what is coming in the results. So let me just put here only, and what I'll do is I'll create a new file here. ABC, let's suppose. Okay, and we will put the results in that. Okay, as soon as the results will come, I'll just simply put it in that. Okay, so let's suppose this came, I'll copy it, I'll put it here. Okay, now the whole result came. Let us see. Okay, this time we don't need to worry on that. So, okay, great. So let's start with the call one. It started, what is the weather in Bangalore and when did RCB win the IPL? If you're unsure, then use the tools and the subagent. Okay, that's fine, good. So first it is making the tool call, and it is calling the get city coordinate. So you can see that it is every time able to identify that, okay, I cannot directly get the weather of a city. First I need to get the coordinates of the city, and then only I can get the weather, right? So the first tool call will be this, and it will hit it, and then it will get the results, and those results will be then passed to the next tool call. Okay, so you can see that it is a tool call and all, and you can see here, like all the details it is trying to put over here. So all these are happening, and then after this what it is doing is it is having the results now. So before having the results, it is now creating this particular thing. So it is going to call this with this. Okay, and now the tool call is completed. So the moment tool call is completed, this result now will go for the next one, right? So we'll be having the results in this. So now the tool call 2 will be called, and here you can see that it is going to make that call, that okay, get city coordinates for Bangalore. This was the one, right? And city is Bangalore and all, and it is making this, and then we are going to make the call, like we are going to get the result. So you can see that here is the result that was received. So now this result will be passed to this particular function. So you can see get weather coordinates, and in the arguments we are passing the latitude and the longitude. You can see this, right? Now this function, again, the the whole structure and everything is there, and then it will be called. So once the call is completed, so at this point you have the weather details now, right? Now it has to identify that, okay, when did RCB win the World Cup, right? That also it has to identify by itself. So you can see over here, okay, this is the model call. So whenever there is a tool call, you are seeing the tool call. Whenever there is a model call, you are seeing the model call, right? So middleware see tool call, and then the result is again given to the model. So this is the model call, right? So model middleware is coming now. So it has two results now. First, from city it was able to get the coordinates. From coordinates it was able to get the weather, and now it is making it is going to identify the third part of it, which is like when did RCB win the World Cup, right? So that is what it has to identify now, correct? So you can see that it is calling the middleware, again the tool call 3, and in this tool call you can see that it is going to call when did RCB win the IPL, right? So see, it has rewritten our query, sorry, not rewritten. When did RCB win the IPL? Please provide the year if they have won, or a state that they have. So you can see that it has actually made the query better, and then it is going to make the tool call for us, right? So it is going to make that particular tool call to the Taveli client that we have created, and from Taveli you will get some results, right? So that is what you will be getting in the content of that. So here there will be somewhere content.